No, Fabrizio.
Hello. Can you
Hello,
hear me?
everybody.
Yeah,
Yes, we can.
it's good. I just wanted to test a bit the visual and if it works. Okay, we'll switch off the microphone now.
Yep.
Because we still have a bit of time, I will just try to share my presentation that I will not be.
Hello, Tanya. Nice to see you.
Hello, hello. Does it work now? Yeah, you see?
Yes.
The present. Yeah,
Yes,
okay.
we
Then I
can
will
see.
Yeah, all good.
Okay, stop sharing.
Mm-hmm.
Excellent.
Hello, everybody. How are you? Fine?
Hi, hi.
Very well, thank you. How about you?
Oh, good. Good. I would say good. Yeah.
You're too busy with a lot of things.
Ciao, Tanya.
Hello.
Hello. Hello, hello, hello.
So Fabrizio, is it okay that you will be sharing the first slides, so we go back and forth?
I will share the slides, no problem.
Okay, good.
How many people are registered?
We don't know because we decided to not do a registration type, so there's really no way to track. We wanted to sort of keep it public so that anyone could share. After some discussion, we decided to do it this way, so we don't really have a measure right now, sadly.
No, it's good that you will measure only those that they will really come. Because sometimes people, they register and then, you know, they don't show up.
They don't join yet.
Yeah, we originally wanted to do it that way, but it was sort of this enclosed circle that we didn't want to really keep. So it's this open format. We'll see who joins and who doesn't?
Okay, let's see. Let's see. Mary's was very nice. There was several presentation on I would not say not, but 2 or 3 presentations about the stakeholder
afternoon.
engagement. Ciao, Robert. How are you?
Oh, yeah, very well.
Well, you are in the cell, yes?
Yep.
Very good.
Good afternoon.
Good afternoon. How are you?
Good afternoon.
Hello. I'm good. How are you?
Fine, fine. Thanks. Thanks for joining. Hello, Jerry. Good afternoon.
Yes, hello, hello.
Thomas, in principle, we should start because it's 1 p.m. Maybe we wait for a few minutes.
I would if we're gonna wait, I would wait for like maximum 5 minutes, and then I would say we kick it off.
Okay, good.
Also, anyone should have the option to share their presentation. So Fabrizio or Atta, if you're gonna be sharing, feel free to. You can start it whenever.
Okay, good. So we wait for 5 minutes and then we start. Hello, Mary. Hello, Melis.
Hello, hi. Good to see you all.
Good to see you too. We just wait a couple of minutes, giving the time to other colleagues that are going to join, and then we may start our webinar. Okay, I suggest to start. So, good afternoon, everybody. Welcome to the webinar SMR risks, risk perspection and risk communication organized in the framework of the SANE project funded by the European Commission. And I would like to introduce our coordinator, is Mr. Herminen from VTT, and I would like to thank Mrs. Airola and Mr. Sobotka, who take care of all of the organization of the webinar itself. So I would like to start with an introduction presentation provided by Mr. Herminen. I just give me the time to share my presentation. So I think that you may see in.
Yes, we can, Fabrizio.
Yes, okay,
Yes.
good, very good. So, and I leave the floor to Mr. Herminen and with the safety assessment of non-electric users of nuclear, so namely the SANE project, and with some words of introduction. Please, Herminen.
Thank you, Fabrizio, and very welcome to this first webinar of SANE project, safety assessment of non-electrical user for nuclear energy. This is funded by European Commission training education funding and also the Swiss Confederation funding. Please, Fabrizio, next slide. Motivation for the project is basically the European Union's transition to net zero carbon economy by 2050, and we see that the nuclear energy has a great potential for this to help this transition. The current production of global nuclear power is concentrated on electricity production. It's somewhere in 2,500 terawatt hours yearly, and this probably will continue as such. But then there are non-electric applications where nuclear power can provide significant help. But the thing is that currently these are much lower volume than the electricity production. Here you can see in the top side of the slide is that they are in a gigawatt hour volume, while the electric production is in terawatt hour. So it's 1,000 bigger volumes. How the SANE aims to facilitate this path towards the potential, for example, in electricity production, it's still in EU. It will remind that the current fleet will come to its kind of a most of it will 80 gigawatts of the fleet, which is currently about 100 gigawatt. The power capacity will be phased out basically by 2050. So this needs to be already replaced. So that means 80 gigawatts of new production. And in order to reach the targets of net zero production, it means that we need to have about 1,700 terawatt hours of extra low carbon electricity production. Other fields are the hydrogen production, which is the European Commission has said that Europe will produce like there will be 20 megatons of hydrogen, renewable produced hydrogen production per year by 2030, and half of this is supposed to be domestic production and half imported. But this already requires about 1,000 terawatt hours of new electricity production. Then one of the hardest target is the industrial heat, which is the largest and hardest to decarbonize energy demand in Europe, and this requires about 1,250 terawatt hours of heat per year. Over 45% of the market is low heat, so below 400 degrees. So this is where especially the SMRs can these light water reactor SMRs can help significantly. Then there's the district heating, which is about 500 terawatt hours of heat yearly in EU, and 2/3 of this is fossil fueled. So nuclear power energy has a strong technical and economical potential to supply this low carbon heating, especially where the district heating network is already existing, and this demand is constant and continuous, and there are no other ways to decarbonize this base load. Next slide, Fabrizio. So the SANE project, the main objective of SANE is to investigate the potential of nuclear energy to supply services other than the electricity. We have four work packages, technical work packages, and I have here gathered them to basically these kind of a basic research questions which each work package is trying to answer. The first one is about that what are the possible non-electric applications. So here they are studying different feasibility of non-electric use of nuclear energy in different application domains, such as process industry, district heating, heat for agriculture, hydrogen fuel production, etc. And the second work package then is the safety questions. So in order to this to be reasonable way to help this net zero carbon target is that they need to be safe, and then we have to study that, okay, how these for example small modular reactors, how they differ from the conventional large power reactors. Then the third one is how can they be used. So this is basically how to couple the nuclear power plant and its non-electrical use. Feasibility and performance studies are done here. And then the last, which is basically the topic of today, pretty much that how can we discuss them. So improving communication of risks arising from the non-electrical uses of nuclear reactors, and particularly for SMR for heat production. We have 11 participant organizations from nine different countries. We are about the halfway of the project, so we are starting to get results, and this will last until next year, autumn, and the EU contribution is about 3.5 million. Thank you.
Thanks a lot, Atte. And we move to some introduction to most related to the topic of today. So inside SANE, one working package is completely devoted to the risk communication, with one main goal, so the exploration and identification of ways to improve the communication related to risk. When we think about the deployment of new technologies, and in particular new uses, particularly the non-electric use of SMRs. And having this in mind, the final goals is the development of strategies and roadmaps for the risk communication with different kind of inputs. So first of all, of course, a key input comes from the public and the other stakeholders, and asking them their views regarding the development of these new technologies and their uses. At the same time, another input comes from a comparative analysis on radiological consequences of accidents in these systems, plus lessons learned by the Ukrainian colleagues related to the risk communication and related to the actions in crisis periods in the Chernobyl exclusion zone in Ukraine. Plus, of course, the outcomes of the safety studies just mentioned by Atte in the rest of the dedicated working packages in the SANE project. Regarding the methodology, we have two main pillars. On one side, we wish to build a database which include not only the technical information, technical, of course, engineering related information related to the systems and the safety assessment, but also social and ethical information. And these are meant to be converted inside the project in the proper risk communication strategy. And having this in mind, we are working on reviewing the existing procedure and the arrangements among the different EU countries. We are proceeding to the estimation of radiological consequences of accidents in different nuclear technologies. Of course, the feedback from the stakeholders is a key issue, particularly when we think about a novel application of a nuclear. And the Ukrainian case study is relevant to also support these activities. The second pillar relates to the social and ethical aspects, having in mind the development of the use of ethical use of nuclear energy. And the main goal is providing a much deeper understanding than the state of the art of the social and ethical dimensions of these new technologies, and to contribute to a more informed decision making. And having this in mind, the colleagues in the working package perform a quite large literature reviews. So we are going to perform, we have been performing interviews and workshops with the stakeholder groups that you may see is a wide researchers, policymakers, industries, NGOs, and with the main, I would say main question is how these different stakeholders may imagine the implementation of this novel nuclear application at a different level, so ranging from the social to the economics through the political. And of course, and this is a key issue in SANE, we want to, of course, compare the nuclear industry risk with other risks from other industries, as you may have seen in the previous slides from Arte. And therefore, the webinar today is well focused on this topic, and all different topics will be touched by the colleagues, which I thank since now for their efforts, which will present for presentations, and each presentation will last about 20 minutes plus 10 minutes of question and answer. And we will have a break in the middle, and finally we will have an overall discussion about the outcomes. So this is that's all on the side of Ate and me. If you don't have comments or questions, I propose to start the webinar with the first presentation, SMR radiological risks basic principles. This is presented by Paul Brother and Guillaume van Onderen by Energy Palace. Please, Paul, Guillaume, the floor is yours.
Thanks, Fabrizio. I will share my screen. Can everybody hear me?
Yes, yeah? We do.
Okay.
Yes, we do.
Perfect. So I'll start with the presentation, and my colleague Guillaume will take over in the middle. So as already was introduced, the SANE project or SANE project, it always depends on how you how you pronounce that, is regarding the potential of nuclear power. But most of the cases we are studying within the work are actually based on SMR technology. And even though most of you already know what an SMR is, we thought it was a good idea to start with the basics and start with the beginning and explaining what an SMR really is, what the application domain of an SMR is, and then more in terms of nuclear safety before we dive into the risk, which was of course the topic of this webinar. A couple of words on nuclear safety principles. And my colleague Guillaume will wrap up this presentation in terms of the radiological risk items. So small modular reactors are an innovative family of reactors, and they are distinguishing themselves from large reactors in the sense that, well, part of the word already says this, that the reactor is small when we look at the electrical outputs. And it's usually below, but not above, as per definition, not above 500 megawatt electric. It's always measured in terms of electrical output. The reactor is modular in the sense that the constituents, so the compartments and the components of the reactor are factory made. And it features facts which you don't not necessarily see in large reactors, is that they can be multiple units realized in the same location, in the same reactor site. And in the end, of course, the R in SMR stands for reactor, because we're talking about a nuclear reactor, even though it's small, where nuclear fission is producing the heat. As I mentioned, SMRs distinguish themselves based on the size and how they are produced. Typically, reactors under 500 megawatt are considered small, and 500 megawatt is even the upper limit of the SMR classes, the SMR range. Usually, it's around 100 to 300 megawatt electric. And this modular, as I mentioned before, refers to the ability to be produced in series. It's basically factory-based, and they are assembled on site. That's supposed to be a way to speed up and enhance the building time, and in turn the costs related to SMR deployment. And of course, maybe you've seen it in the news, the BWRX-300 is under construction in Canada. This is an artist impression, let's say, of how the reactor should look like when it's done, and you can see that it is relatively small compared to large power plants. When we talk about SMR, we should talk about different kind of types of reactors, and they come in various shapes and sizes. The distinction is basically based on the design, or in terms of the fuel type, and in the usage of various coolant types. In the end, they're all based on the same principles, of course, because it's physics and it's nuclear power, but they have different properties and with that different applications. We have the small modular water-cooled reactors. These are the little brothers and sisters of the larger power plants deployed and operated worldwide. Then there is a flavor of liquid metal reactors. There's a flavor of high temperature gas-cooled reactors, which it's gas-cooled, of course, as the name suggests. And lastly, but not least, there is the molten salt reactor type, where the fuel is dispersed in a salt, so there's no solid fuel anymore. The fuel is already molten. It's good to mention and good to know and good to note that different fuels in these cases also produce different types of nuclear waste. And since the mechanism, the physics involved in these designs, the operational temperatures also vary widely. And that brings me to the fact that we can actually look at what we can do with these kinds of reactor types, the application domain. The most apparent difference between these reactor types is the range of applications as related to their operational temperature. Conventional reactors, like light water reactors, pressurized and boiling water reactors, have an operational temperature of about 300 degrees C. These are advanced reactors, so the other three I was highlighting in the previous slide can, depending on the design, go up as high as 1100 degrees C. What is important to note here that a higher system temperature allows for a higher efficiency in terms of we can, in a more efficient way, produce electricity, which basically means that we end up with having a lesser amount of waste heat. But since in the same project, we do not look at electricity production, we can also power, let's say, different kind of industrial processes. And when you paint the picture of all of this is basically how it looks. We can grab a pointer. Here we can see that we have light water reactors up to 300 degrees C, but if we choose to deploy other kinds of more advanced reactor types, we can beam up this process temperature and therefore power more energy demanding industrial processes. So that's basically a generic picture, an overview of what SMRs are and what SMRs can offer. In terms of nuclear safety, there are a couple of principles we have to live by and we have to stick to, let's say. In terms of nuclear safety, there are three main safety functions which should always be maintained. They are in order of importance: the control of reactivity, which means we need to be able any design, any type of reactor, any process operating temperature, we have to make sure that we can power control the reactor to prevent power surges, and in case of emergency or normal operation, but when we are shut down, we need to be able to keep the reactor shut down. That's of utmost importance. The second tier is the cooling. All elements which produce heat should be sufficiently cooled to prevent any kind of damage. And if we succeed in those two, we can also succeed in the third and last criterion, which is the containment. We have to ensure that reactive materials should be contained to prevent environmental release of radioactivity. I think my colleague is now taking over. Guillaume?
Just to slowly step in, sorry, there's been a question in the chat from Mr. Nazarov, and the question is probably aimed at you, Paul. What is the source of the 500 megawatt definition for SMRs?
I think it's a very good question. I don't really know the real answer to it. All I know is that in the past there have been two definitions roaming around. One definition was based on the IEA nomenclature. Again, if somebody else wants to interrupt and correct me if I'm wrong, then please do so. And the other one was based on the definition as used by the US Department of Energy. And the difference was that one was looking at the sizing, and the other one was looking at the size of the outputs. And in the end, I think most of the designers is sticking with this 500 megawatt as an upper limit. And most likely there's also a very good explanation and reasoning behind it from the designing point of view. But technically you could go as high as you want, because of course we also have been deploying large power plants in the past, and we are still foreseeing deployments of new large reactors worldwide. But I think this is more of a magical crossover, or like a threshold of which most designers try to keep below it, because smaller means more versatile. Smaller means more flexible in the sense of operation and of deployment of building, etc. So it's kind of a golden rule without any harsh and hard reasoning behind it. But if anybody else has a better or an addition to my explanation, please feel free to add.
No, thanks a lot, Paul. I do confirm that usually is the definition that the definition is a classification that usually comes from the International Atomic Energy Agency.
Yes. Yeah. Exactly. No, and it's maybe nice to mention in this sense, like you have small modular reactors and you have large small modular reactors, and of course large tend to traverse towards this 500 megawatts, and the biggest SMR is the Rolls-Royce SMR, which is developed by Rolls-Royce in the UK, of course, and it's 485 megawatt electric, I believe. So that's the upper limit of the spectrum of SMR technology, and it's light water cooled. Let's see, are there any other questions in the chat? No, I don't think so. Any other questions from the audience?
Yes, Tanya, thanks. Yes, exactly.
Okay,
All right.
Thanks a lot. My colleague will take over.
Please, Guillaume, go on.
After that intermezzo, we'll continue. So Paul just told us about what the fundamental safety objectives are of any type of nuclear reactor. And these safety objectives are achieved using either inherent safety features of the reactor or by engineered systems. And when we're dealing with engineered systems, we also always have the possibility that things go wrong. So if these safety systems fail, then you might have a situation where the plant develops an accident. And if you have an accident, that means that there may be a certain risk associated with this. So the safety goal of a nuclear installation should be that the risk is as low as possible, and definitely low enough to be acceptable. So to understand what that means, we need to look at the definition of risk. And risk is just the product of consequence and probability. So if we say that something has a high risk, we can either say that there is a very small probability that something goes wrong, but when it does go wrong, it has large consequence. Or we could say that something has a high probability of occurring, even though the consequences are relatively small. So if we look at that in a graph, we could plot consequence versus probability, and we could make various different, place various different events on this graph in order to compare what the risk is of different events with different probability and consequence. Now, some of these events are acceptable and some of them are unacceptable, and we distinguish those two using a radiological risk limit. So we can draw a line on this graph and we could say events which are above this line are unacceptable, marked in red, while events that are acceptable are marked in green. So for any event that is reasonably can be expected to occur, meaning it has a high probability. So in that sense, we are in the, let's say, the top part of the graph, so high probability events, then the consequences must be very low for them to have an acceptable risk. While at the same time, if we look at events which have a large consequence, so that's the right side of the graph, then the probability must be very low for these events to be acceptable. Now, of course, these installations don't exist in a vacuum. If you're building a reactor, you're going to build it at a specific location. And specific locations have location-dependent factors which determine what the risk is. So if you have a reactor which has, let's say, an accident, then you also want to look at who is going to be potentially at risk during the event of this accident. Regardless of where you're going to place it, you're always going to have to comply with very strict risk limits. But whether or not you can meet those risk limits depends on the combination of the specific reactor and the surroundings. What this also means is that, in principle, any location could be suitable for placing an SMR, even if that location is close to inhabitants, as long as you can demonstrate that it is sufficiently safe. And this is where it's important to distinguish between different reactor types. So each type of reactor has its own specific risk profile. Especially advanced reactors have the advantage that they can be inherently more safe than other types of reactors. And that can either be due to the fact that the consequences of severe accidents being smaller, or that the probability that these accidents occur are smaller. There are various reasons why this could be the case for advanced reactors. But one example could be that they rely more on passive safety features rather than engineered safety features, which means that they are less sensitive to, let's say, failure of components. Well, everything I've told you up until now is related to accidents. However, under normal conditions, the inhabitants which are living around an SMR or any type of nuclear installation may not experience any significant additional radiation exposure. So we're all constantly exposed to small amounts of ionizing radiation. Major sources are just cosmic radiation coming from the sky above us, or we can be breathing in naturally occurring radioactive gases, which are emitted from building materials. So we have a constant low level of exposure to ionizing radiation, and the operation of a nuclear reactor cannot increase that radiation burden much more than it already exists due to natural sources. Now, I've spoken a lot about the consequences of, let's say, accidental events, but it's also important to express what we mean by that and how we evaluate that. So to look at what the risk is of a nuclear installation, we perform a safety assessment. And in such a safety assessment, we look at many types of different scenarios of things that could go wrong. And in many of those events, it could be that there is a release of radioactive material into the environment in which we have an exposure of the population around it to radioactive materials. So what we need to do is to understand what the potential consequences are of such an event. So we do this by simulating such an event using computational models. So we look at if we have a release of radioactive materials, how does that transport into the environment, what dispersion happens, where does it go, and most importantly, who's being exposed to this emission. So on the image on the right-hand side, we see some examples of phenomena which are important when performing such an analysis. And we also see that there are various different ways that you could be exposed to radiation if there's a release of radioactive material. So examples include direct exposure due to a cloud of material, which is above you or which you are inhaling, but also more indirect pathways where radioactive materials are traveling into the food chain and you could be consuming materials or let's say food which contain radioactive materials which are being released. Now, in such an assessment, it's important to also look at the effect of countermeasures. So if an accident would be to take place, then the local safety authorities would undertake actions to ensure that the exposure of inhabitants is as small as possible. So they can do this, for example, by asking you to shelter in your house, or if the accident is extremely severe, it could even warrant an evacuation. Here it's also important to mention that we need to take site-specific information into account when performing a safety assessment. There are two examples I want to highlight here of relevant information, which is site-specific and important for a safety assessment. The first one being the local weather conditions. So you can imagine that if you have a nuclear installation which is situated near the coast, you will have higher winds. You can have more precipitation, for example. And as you can see in the image above, those are factors which determine the level of exposure of the people who are around the installation. But you also have to look at who is at risk. So in the bottom image, you see a population distribution where we look at different groups of people who are living in different areas and exhibit different behaviors. So it could be permanent inhabitants, but also tourists or people who are at work. And all of these people have different habits and they get exposed in different ways. So for each of those groups, we want to understand what their level of exposure is and what that means for the risk that they experience. Now, the purpose of this analysis is first and foremost to demonstrate that the risk is low enough to be acceptable. So it has to meet some regulatory risk limit for when the safety authority can say, I see that you have properly demonstrated that the risk is low, and we as a society accept that this risk is low enough to be acceptable. However, at the same time, this analysis can also be used to inform emergency preparedness planning. So if something does go wrong, the safety authorities need to undertake actions to mitigate the consequences as much as possible. And to do so, they need to have a proper understanding of where this material would go, who is going to be at risk, and what the effect is of countermeasures in mitigating this risk. And by doing so, the safety authorities can be as prepared as possible for the unlikely event that something does go wrong. So a summary of what we've told you. Firstly, Paul told about what SMRs are. which is a small and versatile type of nuclear reactor. The features of SMRs makes them a useful asset in decarbonizing the energy system because they can be used for a wide range of applications. Just like any type of nuclear reactor, SMRs need safety features to ensure that they comply with the fundamental safety principles. And if those features fail, we need to demonstrate that the risk that this SMR causes is sufficiently small for them to be licensed by a nuclear regulator who will test this against the applicable risk limits. And when performing such a risk assessment, you always need to consider the surroundings of the reactor to understand who is actually at risk. So that's all from us today. Thank you for your attention. If there are any more questions, we'd love to answer them.
Thanks a lot, Paul and Gideon. Are there any comments or questions to them?
Yeah, I would like to indicate the discussion I had before regarding the definition. As I mentioned, there were two different definitions in the past regarding SMRs. In the end, the one that sticks is the 500 megawatt as an upper limit, but that's not in line with what IEA is calling an SMR. Again, in terms of the IEA definition, it's up to 300 megawatt electric, and most of the designs are actually at 300 megawatt electric or below. I think somebody showed an infographic regarding the SMR which is being 20 to 300 megawatt electric. Well, that's not even true because you can have small modular reactors as low as 5 or 10 megawatt electric. Again, that's not the light water reactor type. It's more advanced systems. They're not readily available or on the market or deployed yet, but designs again can go all the way from very small, which we call micro reactors, up to 300 megawatts compared to the definition of the IEA. And the same infographic showed for large power plants 1,000 megawatt electric. Well, that is even small nowadays because I believe Olkiluoto EPR is able to supply 1,600 megawatt electric. So the distinction between small and large is even larger today than it was in the past. That one I wanted to add that.
Other comments or questions? If I may, I have one, mostly related to the also to the next presentations. Okay, Guillaume, you mentioned in your presentation about how the safety assessment is performed. Of course, it's very. It would require very long discussion about that, but just to make more clear to maybe non-nuclear guys. So what basically means, so based on what you select some scenarios, because of course one cannot analyze, or better, one analyze all the possible scenarios, but at a certain point there is a sort of ranking. Based on that, some possibilities are more, let's say, can be considered completely impossible or with a sort of frequency or sort of probability to occur. So Justin, may you briefly comment on that?
Yeah, so in such a safety assessment, we look at a wide spectrum of possible scenarios which could occur. So the most, let's say, scenarios with the lowest consequences typically need, let's say, less features to fill at the same time. Mm-hmm. So you always have some initiating event which causes an accident. So it could be that you have a component which breaks, or you have an earthquake, or it could be an external hazard, it can be an internal hazard. Something initiates an event, and then you would need a sequence of components to, let's say, fail at the same time in order for the fundamental safety principles to no longer hold and your reactor to or evolve into an unsafe state. Depending on how many of these components fail at the same time, you will end in a scenario which has a lower and lower probability, but also larger and larger consequences. So we look at this full spectrum from things that are very likely to occur, which could occur, I don't know, every day, every week, which is completely inconsequential, or something which is only going to happen once in a million years due to a very unlikely sequence of events occurring at the same time. So it's important to not only look at things which can probably occur, but also things which can unlikely occur due to the combination of circumstances being so rare.
Thanks a lot, Guillaume. I see in the chat a comment from Tanya, which is relevant to your presentation, but I think that it will be partly touched also or discussed, or could be also harmonized the framework on the next presentation. So therefore, I think, Tanya, we may propose to proceed, and then maybe we come back again to this point. What you think is okay for you? Oh, please, Robert.
Sorry, that was in an attempt to start sharing the screen.
Okay, good. So, okay, so I assume that Tanya agrees on my proposal. So thanks a lot,
Yeah, of course.
Paul, Guillaume. I kindly invite Katerina Turcano and Robert Gamesmans to share the presentation. The title is How is the public perceiving SMRs? Really, really tough question. So please, the floor is yours.
Yes, thank you. Well, I'm Robert Gijsmans, working as a sociologist for the Belgian Nuclear Research Center, and I'm giving this presentation together with my colleague Katerina Turcano, also from the Belgian Nuclear Research Center, and we will indeed discuss this, well, as you call it, a tough topic, Fabrizio, but it's, well, how is the public perceiving small modular reactors, and particularly also maybe the non-electric applications of small modular reactors. So why is it important, of course, to look into public perceptions? Well, as has already been indicated in the first presentation, of course, small modular reactors are one of the major technologies that are currently being looked at in the discourses on the nuclear renaissance. A lot of countries are showing interest in developing or have quite concrete plans into actually implementing small modular reactors in the coming years and decades. These are just some examples at the European level. And of course, this offers us quite some technical challenges, some safety challenges, and these have already been pointed out also in the previous presentation. But of course, we can't kind of forget, well, why are we actually implementing these technologies? And this is basically to answer to specific societal needs, expectations, concerns regarding safety, regarding energy provision, regarding sustainability, and to kind of understand the way in which these technologies are or are not meeting these societal needs, expectations, and concerns. One of the important factors to understand, of course, is also, well, how are different publics actually perceiving these SMRs? What are their expectations, their concerns, their potential needs regarding small modular reactors? And that's what we will be kind of looking into in this presentation. We will draw mostly on data which actually comes from Belgian studies, although we will also draw a bit, as Katrina will point out, to other countries as well. But given that we are mostly focusing on Belgium, just to kind of set a scene, a bit of the nuclear context as it currently is in Belgium. So Belgium has a quite established history of nuclear energy use, particularly in its electricity grids. So we had, until a couple of years ago, we had 7 operational nuclear reactors within our MPPs. However, at the start of the 2000s, there was a law on the phasing out of nuclear energy voted by our then parliament. which meant that the intention was to actually close down all of our reactors by 2025. In the meantime, we have had quite some yes-no on whether or not we should pursue this, with the latest development actually being that in 2025, the phase-out law was reversed. However, by that time, already 5 out of the 7 reactors were being shut down. So there's currently only 2 out of the 7 reactors which are still operational. Nevertheless, our current government is looking into the potential of new nuclear. So actually there's an interest in kind of maybe keeping the currently operational nuclear power plants operational for a longer time, and maybe even reopening some of the existing ones which have already closed down. There has been actually last week some talk about nationalizing some of our nuclear reactors. And in parallel, our previous government has already shown its support towards small modular reactors, or at least its interest towards small modular reactors, by dedicating funding towards research on small modular reactor technologies, particularly here at SCKCN. And in the Belgian context, the SMR technology that is being looked at is the LFR SMR. So that's a lead-cooled fast reactor SMR, which is being developed in the broader European EAGLES consortium. So we see that currently in Belgium, there is kind of a national, but also regional, so at the Flemish and the Walloon levels, push by policymakers, but also by some industries towards the implementation of small modular reactors in the Belgian energy landscape. And of course, then the question that we as social scientists have, and this is also the topic then of this presentation, well, what do actually Belgian citizens think about small modular reactors and their potential applications?
So if we look at the literature of social scientific studies analyzing nuclear energy, we see that this has been studied quite extensively. However, there has been comparatively much less focus on emerging nuclear technologies, such as SMRs, and even less focus on the non-electric applications. In the framework of a recently completed European project, EcoSense, we carried out research in several European countries in order to understand indeed what are citizens' views and expectations of SMRs, how do they see them compared to traditional reactors or other energy sources, such as, for instance, renewables, and to what extent climate change concerns or energy security concerns and other sustainability-related aspects shape these views on SMRs. And in order to capture both deep insights as well as to be able to make generalizations at larger population groups and study causal effects, we have applied a mix of qualitative and quantitative methods. The qualitative methods were focus groups with citizens in a location which will host a demonstrator of an SMR, and which happens to be also the location where there are active partnerships for radioactive waste disposal, but also with broader public, such as, for instance, students at the University of Antwerp and other members of society in Flanders. In the case of surveys, we did a survey with a representative sample of the Belgian citizens older than 16 years old, and this sample was representative for gender, education, province, and age. The data for both the focus groups and the surveys were collected before December 2024. So just to locate this data collection in the timeline that Robe presented, this was at the time when the phase-out law was still in place. What we can notice when we look at the Belgium in particular, is that citizens' attitudes towards nuclear energy have become significantly more positive if we look at 2024 compared to 2021. Obviously, the war in Ukraine and the ensuing concerns about energy security were very important to explain this evolution. For instance, we see that in Belgium in 2024, 4 out of 5 people said that they were worried that electricity will become unaffordable. But also there has been increasing concern related to climate change, and a large majority of people in the survey, for instance, they thought that climate change will have important consequences, even at the personal level. So for what we call people like me. So 3 out of 5 also say that they are worried about the climate change consequences. Important here is to note that these more positive attitudes towards nuclear come in the context where still the preferred energy mix in Belgium is actually a mix of nuclear and renewables. There is also a clear preference towards an important share of energy generated by renewables, but nuclear energy is also seen as having a role. So considering also this preferred mix, it seems that SMRs could provide an interesting technology for the future. However, what we have seen in the survey is that at least in Belgium, but not only, also in other countries like Czech Republic, UK, Spain, there are very few people who actually know what SMRs are. For instance, in Belgium, 55% said that they never heard of them, and 27% said that they heard of the term, but they are not sure what they are. So in that sense, it is clear that while there are so many discussions in terms of the potential role of SMRs in different countries' energy policy, there is very little information that actually trickles down to the citizens. And for this reason, it is also difficult to capture opinions. We have, in our survey, anticipated that, and we have included an information segment where we've relied on the information from the International Atomic Energy Agency, which explained some of the, let's say, general features of SMRs that were also introduced earlier, about the size, that they are smaller, modular, but still also reactors, so basically using nuclear fission to generate heat and produce energy. And we have also presented this figure for a better understanding of what an SMR means. We mentioned also in this information segment, and actually both in the survey and the focus groups, that the goal of studying SMRs was the search for reliable low carbon energy sources, and also to improve some of the characteristics of existing reactors. Nevertheless, we mentioned that the technology is still under development and not a proven and ready-to-use solution. And also importantly, in all the survey items, we clearly use the terminology small modular nuclear reactors to be sure that we actually convey this message that while they are mostly known under the name small modular reactors, we are referring actually to nuclear energy reactors. So what is also interesting is, okay, given such information, how do people perceive the potential role of SMRs in addressing some of the problems that I mentioned? So for instance, mitigating climate change or ensuring energy security. And what you can see in this graph, which actually presents Belgium in comparison with other countries. So first you see that, in fact, in Belgium, more than half of the people tend to agree that small modular nuclear reactors could make an important contribution to reducing carbon emissions. What is also interesting in this graph, and that is why I included the 3 countries, is that there are clearly national differences. For instance, in Belgium and Czech Republic, that are more favorable to nuclear energy in general, there is the potential benefit of SMRs to reducing CO2 emissions is also recognized to a larger extent than, for instance, in Spain. What this also graph shows us, and is very interesting to notice, is that although in Czech Republic, the public is in fact even more positive to nuclear than in Belgium, this does not automatically mean that the benefits of small modular reactors are recognized in the same way as for large traditional reactors. And in terms of the perceived role for SMRs related to energy security, and in particular, keeping the the electricity at an affordable price, very similar results were obtained with more than half of people in Belgium, for instance, saying that they thought that SMRs could help prevent electricity shortages and keep the price more or less affordable. What is also important is that about 12% actually could not formulate an opinion, presumably because they have never thought about SMRs. We have seen that many people, they don't know actually what they are. So in that sense, for different members of the public, it is still difficult to formulate an opinion about what they expect from these new technologies. In general, though, the attitudes expressed in the survey were quite favorable for both electric and non-electric applications. And what you can see in this graph is a distribution of the extent of agreement with building a small modular, a small nuclear reactor inside one's municipality or city to serve as a heating plant. In fact, you see that there is, well, quite a balance between agreement and disagreement, and also with 1 in 3 being either neutral or not being able to express an answer to this question. Proximity surely plays a role because if we, for instance, look at support for building an SMR in various siting configurations, we see, for instance, that about 1/3 is in favor of building an SMR within 10 kilometers from the residence, while support increases significantly if that would be placed further than 10 kilometers, or even better on the site of an existing nuclear power plant. In the literature, there are several socio-psychological factors that have been shown to shape support for nuclear energy. And in a recent study we did for the SANE project with my colleague Tanya, we look to what extent these factors also influence support for SMRs. And we have been able to show that perceived risks, perceived benefits and risks are the driving factors for support for SMR. In particular, the energy security benefit is the strongest factor shaping support for SMR. But a second important perceived benefit is related to environmental friendliness. Societal risks, perceived societal risks, like for instance of future generations or safety risks, are a second important factor shaping support. And last but not least, also fairness of decision making. So if people believe that a citizen's views are taken into account in nuclear decisions, and also that decisions on siting are fair, then they are more likely to support, to express support for SMRs. Apart from this, there are also other variables that have an indirect effect, meaning that they influence support for SMRs through the perceived benefits and risks. And these are affects, so positive and negative emotions raised by the development of SMRs, for instance, hope, interest, or on the other side, worry or anger, but also trust, and in particular, social trust. This meaning trust in the actors that are dealing with the risk management related to nuclear installations. Also interesting is that the potential benefit of SMRs for reducing the carbon emissions as well as the socioeconomic benefits for communities, were also positively correlated with support for SMR, but they were not significant in the final model. This meaning that their role is actually taken over by other variables included in the model. So for instance, in the case of CO2 emission reduction, it is clear that the more people believe that SMRs will help with reducing emissions, the more they support. However, it is the wider environmental impact of SMR that is actually playing the dominant role. And finally, one thing we have noticed in the surveys is that there is a clear need for participation. I already mentioned that procedural justice, so fairness of how decisions are taken in terms of SMR, is an important factor. In the case of Belgium, this procedural justice is evaluated as low to moderate. So for instance, only 1 in 5 citizens express high confidence in the Belgian government, that was in 2024, to take into account public opinion or to act fairly when choosing where nuclear power plants should be sited. So this is an important factor to consider. And we also have seen that there is actually a very large expressed wish for people to be able to be involved in a rather active way in terms of decisions about constructing an SMR in their municipality. For instance, only 18% they said that they would not be interested to participate if there was such a process initiated, while the large majority want to be involved either to know about such an installation, but even more to express an opinion and participate in a dialogue.
Yeah, so well, Katrina has provided some selected results from surveys, which give us, based on closed questions, a bit of an insight in like what lives or what are opinions among the Belgian population. In the remainder of the presentation, I will zoom in on some of these based on the findings that we have from focus group discussions and results. So where it's more of a bottom-up process, let's say, in terms of topics that are being discussed by the participants in the focus groups. When we then look at how focus group respondents describe the Belgian energy context, well, I think what was the most kind of emerging issue was that at the time in which the focus groups were gathered, which was in 2024, 2 years ago, there was a clear perceived lack of a clear energy policy. So it was stated that at the moment, it is not clear how our future energy landscape will look like. There is no clear policy. There seems to be a move towards renewables, but it is not strongly enough supported. Nuclear, its future is also not very clear, because at that time there was already discussions into the extent to which the phase-out law should or should not be followed or maybe revoked. So they stated, well, there is very large uncertain political climate for Belgium, with the noses pointing in 10,000 different directions, and this makes it very hard to kind of go for particular energy options, such as, for example, also nuclear, as we will see in the next slides. And this was considered to be quite problematic in a sense that at that time, the energy landscape was also characterized by increased energy prices and increased energy consumption, which you see all over the world. But also in Belgium, we have a strong push towards particularly also electrification, for example, of cars. And people being worried that, well, given the strong push towards electrification and not having a clear future energy policy, will not meet this rising energy demand. And in general, it was also recognized that, well, Belgium is a small and heavily populated country with little resources which provides for good, stable resources for energy provision. For example, in terms of hydrogen, or in terms of hydropower, Belgium does not really have a lot of natural resources there. Internationally, there was a recognition of geopolitical shifts taking place, and also a stronger awareness about, well, the fact that international dependencies should potentially be avoided in light of these geopolitical shifts. And all of these factors were considered to be quite problematic in light of this perceived lack of a clear energy policy. What were kind of the main issues that people kind of found important when they thought about the energy system in Belgium? Well, it has already been pointed out by Katrina and also emerged in the focus groups. Well, first of all, and I think the most important, was the issue of energy security. And this was actually understood in 3 different but interrelated ways among the focus group participants. So energy security, first and foremost, maybe related to the affordability of electricity or the affordability of energy more generally. People coming out of an energy crisis pointed out that prices of energy have gone up to such an extent that for many people it becomes almost unaffordable. So affordability is a key issue. But also autonomy, and this relates to this idea of international dependency, and particularly the war in Ukraine, pointing out that these international dependencies can be very vulnerable in case that they are disrupted. And the issue of consistency and stability. So the idea of having energy available when it is needed to be available and being available in a stable manner. So these were important issues pointed out with regard to energy security. A second overarching important issue, although maybe a bit less prominent than energy security, was the issue of sustainability. So our focus group participants were aware of climate change taking place and the need in that light to get rid of fossil energy, with some being quite vocal in terms of renewables as the future way to go, and others also pointing towards nuclear as a potential option. So when we then look at how our focus group participants looked at nuclear energy in this uncertain, let's say, Belgian context or uncertain Belgian policy context, there was some discussion to the extent to which nuclear could actually answer to these two issues of energy security and sustainability. First of all, there were those who stated that in light of energy security, nuclear could actually provide a baseline source in a sense that it's not dependent on conditions such as the weather, sunlight, or wind for solar and wind energy. Others, however, stated that nuclear, at least in its current form of being provided by large nuclear power plants, is not very flexible. So in that sense, it cannot provide a stable source of energy in the sense that it follows or responds to shifting needs. Similar discussions arise in terms of the extent to which nuclear is actually, in light of energy security, providing dependency or independency at the national or an international level. Some argued that nuclear could actually be providing more independency given that it is a domestic energy production. Others questioned this domestic energy production by pointing out that actually the sourcing of fuel would anyway need to come from other countries. So there is also there an international dependency being created. The cost of nuclear development and operation was something that was also questioned in light of the affordability. Here it was mostly pointed out that this depended also a lot on the extent to which new nuclear reactors would need to be built or not, and let's say the amount of reactors that would be built and the scalability of this. It was agreed that nuclear does tend to emit during operations lower levels of greenhouse gases. So in light of sustainability, it could be an answer to the challenge that we're facing there. At the other hand, in terms of sustainability, participants also pointed out that radioactive waste is a persistent challenge for which, in Belgium at least, there has not been any kind of long-term policy put in place. When we then look at the attitudes of the focus group participants regarding the SMRs, if we explained what SMRs were, because as Katrien pointed out, a lot of people were not that aware, and also among our focus group participants, there was quite some uncertainty on what SMRs are. But if we explained this, then people seem to be generally in favor regarding SMRs under the condition that they work. However, this does not mean that no questions were asked. Questions do persist about, what to do with the waste, as was also with regard to nuclear in general pointed out as an issue. What regarding military context, and here particularly safeguards were an issue, like to what extent can we make sure that these are not going to be misused as a nuclear technology. And in that light, and maybe more prominently, questions about safety and security also emerged. So to what extent are these reactors safer or less safe? What does passive safety maybe mean in the context of SMRs? This was not always very clear to people. People also doubting claims on passive safety. And in terms of security, it was asked to what extent malevolent actions would be, or to what extent SMRs would be more vulnerable or less vulnerable to malevolent actions in light of nuclear security. In that general sense, although people in general seem to be favorable towards SMRs if they work, there was discussion to the extent to which SMRs would actually be a goal in itself, or rather be a technology of transition towards other better sources of energy. So more renewables or even fusion technology was mentioned there. And then when we zoom into the focus really of SANE and SMRs for non-electric applications, we see that even without probing for this, focus group participants did point out that it could be useful to look at SMRs not just or not even in light of electricity production, but maybe also or even foremost in light of non-electric applications. Two main non-electric uses were mentioned here spontaneously, one being industrial heating and the other district heating. District heating was actually quite interesting and maybe also a bit surprising to us because Belgium really does not have an infrastructure, nor culture, nor a history of district heating. So it was interesting that this actually popped out as a potential application. It was discussed whether SMRs then have a particular advantage in this regard over other nuclear reactors. Some stated that actually it could make sense to go for SMRs for non-electric rather than electric applications. So applications which are different from electricity production. In a sense that, well, they believe that SMRs would not be needed for electricity production because there we would have the large existing reactors, but maybe these SMRs could be then an additional source for industrial heating in particular. And also location could be an advantage because people consider that if these would be safer, it could also be better to place them closer to, for example, industrial clusters or even to city centers. In terms of the comparison between SMRs versus conventional nuclear power plants, well, this was quite disputed. So as some people stated, well, okay, given that they are smaller in size, the risk of small modular reactors is smaller than conventional nuclear power plants. Others stated that, well, that's not necessarily the case because smaller might also mean that it's a more complex technology to kind of fit it all into these smaller reactors, so it might actually offer more risks. Also, smaller size was with some connected to smaller costs. However, others there as well argue that, well, this additional complexity might actually make it more costly, given especially if in Belgium we are looking at advanced designs such as these lead-cooled reactors, and these are first of a kind. This might be more costly to develop and implement rather than proven technologies. Then the larger number was for some put forward as a larger risk. The idea that, well, you can maybe replace one big reactor by 3 or 4 small modular reactors, but would this also not multiply the risk? Others stated that, well, there the number does not really play a role. It's the inherent safety that is important. And then the cleanliness, let's say, and the extent to which SMRs are producing same amounts, more or less waste than large nuclear reactors. This was something that people found very interesting, but for which they could not really find any clear or could not form any clear attitude, given that there's no kind of coherent knowledge on to what extent less, more, similar waste will be generated. So finally, when we then zoom in on what factors seem to be facilitating or challenging the development of SMRs in light of the perceptions of our focus group participants, they considered that currently, again, given the current, or at that time current, let's say, Belgian energy context, they perceive quite some barriers. For example, in terms of economics and economies of scale, they consider that, okay, given that this is a first of a kind reactor, we will probably need to build quite a lot of them for it to become economically interesting. The time needed for development might not be in line with the time needed to take action on climate. Public opinion in general was considered to be a potential barrier, given that, well, people at that time were thinking that nuclear was not that generally favored by the public opinion. There's also a lack of unity and consistency in nuclear energy politics, as was pointed out, and there's a lack of long-term regulatory framework in that light as well, and a lack of convergence at the EU level. In terms of drivers, well, people did consider that Belgium has still strong nuclear know-how, for example, in SEKCN, that there is actually also a potential for economic development and employment being offered by nuclear in general and also then SMRs, and that SMRs could offer a potential for European collaboration. So to end with the final slide also of Catrinel, so in terms of governance and future developments, we see that there is, not surprisingly, a need identified by the focus group participants for a clear policy framework in order to facilitate technological development also of SMRs, but that in this policy framework and decision-making framework, citizen involvement could also be an issue. This was disputed by our participants. So some stated that indeed it's very important to have the opportunity for citizens to express their views, to express their opinions, and to be heard in decision-making processes. Also considered or argued that this could also maybe slow down the process of decision-making. So coming then to a conclusion, well, what we see is in terms of the low levels of awareness among the public, that there is clearly a need for information on SMRs and also on their potential risks and benefits. This is currently, of course, still challenging given that there's so many different concepts going around and that we talk about SMRs without necessarily making that much of a difference or a distinction between different SMR types. So being a bit more clear there could be an important step, also including comparisons with existing nuclear reactors and renewables will be relevant for citizens to form clear opinions on this technology. This also means that the attitudes towards SMR are still developing. It's a rather novel technology. Also, the public discourse on it is rather novel. And given that this information is only becoming available stepwise, we see that attitudes are still being formed. In general, attitudes seem to be positive, and regarding nuclear in general, maybe more positive than a couple of years ago. At the same time, we see also, particularly in the focus group, that the advantages or disadvantages of SMRs are being disputed. And an important aspect with regard to decision-making is the perceived fairness of decision-making, which matters. So the importance of, as Katrina has pointed out, is procedural justice and the idea of giving voice to citizens plays an important role and should be an integral part of decision-making. And with this, I think we have ended the presentation. So if there's any questions, we are available.
Thanks a lot. Thanks a lot, Katrina, Robert. Are there questions or comments? I may have one. So, based on what I see, so people is more. So of course, look at the nuclear side of the sort of non-electric facilities. So having in mind SANE, for example, so they're more aware of the SMR itself and not about the employment of the SMR inside a non-electric framework, correct?
Sorry, can you repeat your question?
Yeah, I mean, so in other words, so people used to look at the nuclear reactors for the electricity production, and based on your surveys, of course, the focus is on SMRs. Okay, but you have also asked about so the SMRs for non-electrical use, so embedded in a framework of sort of small energy city, and so I see that there are more, let's say, any kind of awareness is related only to the nuclear side and not on the integration of the nuclear component with the non-nuclear components, correct?
Yeah, I mean, in the survey, our focus on the use was on the use of SMRs for electricity production, but indeed we included also a question on non-electric use.
Yeah.
What we have seen was that when we look at the general public, there wasn't, I think, so much of difference that we could notice in terms of, for instance, support for an SMR for heating purposes in one municipality versus construction of an SMR for electricity production, also within, for instance, 10 kilometers from the residence. Of course, the survey cannot provide very fine, let's say, details, but in the focus groups, we have seen, and this was, I think, mostly from the focus groups organized with members of the partnerships for radioactive waste disposal that are also rather informed on nuclear issues. So there, the industrial use came quite often, as Robert mentioned, yeah.
And it was indeed their spontaneous mention. So it was not something that we particularly probed for. So it is something that these participants seem to link, particularly with SMRs. And there, if you compare then, and it was, I think in one or two instances, it was mentioned actually by the participants, is you compare then nuclear to non-nuclear, the particular advantage there of the SMRs was pointed towards as also I think Paul in his first slides mentioned, the heat range that these SMRs can reach. So it was pointed out that, well, for some applications, renewables will probably not be able to reach the temperatures needed for certain industrial applications, and there SMRs could play a role. Of course, to what extent this actually meets the expectations of the industry, that's something that still is a bit open, and it's also something that we are looking into in the SANE project as well.
Maybe one additional comment to make is that before we did this research for EcoSense, we also looked at articles published in the media, and it was clear that there was more focus on SMRs for electricity production. There were very few mentions of non-electric applications in articles up to, I think it was March 2024. So even in the media, there was not so much of attention on non-electric applications.
I see two questions in the chat, please. One from Mrs. Fornengo and one from Mr. Nazarov. So, do you know if there are similar studies in other European countries?
Well, so in light of the EcoSense project, so this methodology for the survey was already pointed out by Katrina, was also conducted in Czech Republic and Spain. And also focus groups were actually conducted in these countries.
And Slovenia.
And Slovenia, sorry, yes, Slovenia as well. In light of broader studies on SMRs, I think there are some emerging. I know particularly in Finland, there has been actually also quite some research. Well, you will see some as well in a later presentation today, but also by scholars such as Matti Kojo, Markku Littonen. They have actually looked also at the issue of public perceptions regarding SMRs and public discourses on SMRs, particularly in the Finnish context.
And we also received some requests from Norway and Sweden to include some of the items we have used in EcoSense also for their survey. So in Sweden, I think there will be data available very soon. As to the other question related to the replacement of coal facilities, so one of the focus groups in the Czech Republic, where replacing coal is a very it's a very important issue. So one of the focus groups was at the location of a coal plant facility. So this also shows that, in fact, there is quite some interest. And I also invite you to read. There is one deliverable from the EcoSense project entitled Public Attitudes Towards SMRs, where such particular insights from Czech Republic are also discussed.
Other questions or comments? Okay. If not, thanks a lot again, Robert and Katrina. And based on the agenda, we have the break. We are a little bit in delay, but I propose you to remain with the time slot of 10 minutes. And before going to this coffee break, please look at the chat where Thomas was so kind to answer to a kind of request about the possible availability of the presentations. They will be available on the SANE website. So enjoy your coffee. See you in 10 minutes. So at 40.
Thank you. See you.
Thank you.
Welcome back. We move on for the agenda. So next presentation comes from Maria Aiola from VTT, Perspection and Information Needs of Authorities related to deployment of SMRs for district heating. Maria, please, the floor is yours.
Okay, thank you, Fabrizio, and good afternoon to all of you there. And greetings from quite sunny Finland at the moment. So I think it's nice continuation now to go forward to these kind of other key stakeholders that are sort of involved in this deployment of SMRs. So my name is Merja Airola and I work as a senior scientist in VTT Finland, and my background is more on the organizational sciences or theories, and especially safety culture, safety leadership related topics that are relevant when we talk about safety critical industries as nuclear. And here, of course, it's sort of also a key ingredients when you talk about public acceptance or social license. And this case is not a hypothetical SMR case, so I'm here to shed a bit of light at the same time what's happening here in Finland related to this kind of district heating initiatives. And before I go to that, our sort of case, what we are working on, I will give some details of the background, sort of the societal background, because they are affecting a lot how these technologies can be deployed and sort of moved forward. So I collected here just some details that I think are sort of critical here, but of course there are much more that are affecting how we can sort of make things go forward here. So we are still a high trust society, and this basically means that there is a public trust towards our institution. And in this case, especially our Radiation and Nuclear Safety Authority is consistently among the most trusted authorities. Basically, this means in practice, like citizens in Finland sort of consider that Finland will not build SMR or nuclear in general if it's not safe. And this is, of course, the trust is a tricky thing that you can also start losing it. But this is still a case that there is this kind of features in our society. The other thing that is critical as well is that this acceptance of nuclear energy is very high still and has been high and getting higher. I think it was last week there was a last survey stating that a national survey, so 66% of the respondents consider nuclear energy use positively, and only 8% are opposing. And then one special feature is that municipalities have decisive authority over land use planning and zoning. So they have a veto right of citing decisions. So government cannot sort of overrule them in this case. And what's happening here now is that we have also ongoing reform in nuclear energy regulation. And of course, sort of the licensee still retains full responsibility of nuclear safety, but it's sort of aimed to be technologically neutral, that there is risk-based safety assessment and also flexible emergency planning zones. And then one thing, especially related to our case study, I will soon sort of describe, is that we have this kind of urban diversity as a specific challenge here. Our existing nuclear power plants are more sort of rural areas, and they have been established a long time ago, and these new SMR deployment initiatives are sort of coming straight in the city of our capital, for example. And we have also another city more in middle of Finland that is also proceeding with these plans. So, and the problem here is that we have little systematic data of especially non-Finnish speaking residents. So there might be this kind of a gap in existing knowledge. Also, not just about how they perceive use of nuclear, but in general, how they think our society is like. And okay, let's jump into our sort of organization, end user organization. So it's called Helen, and it's a Helsinki city-owned energy company. that aims to build a SMR for heat production to provide stable emission-free heat for district heating to meet the combustion-free goals. And here in the pictures, you can see that the nuclear is not their only option. So here you can see that they have multiple options to ensure this goal. And this goal is for 2040. And also they just sort of reorganized their sort of structure of their organization, and they have sort of established Helen Nuclear Limited, sort of which organization is in charge of sort of progressing with these plans. And then what's the plant concept like? So this is quite interesting because they have sort of two different options. So it's either light water reactors for heat or combined heat and power reactor. And here you can see a bit of the details and also a picture from their website how they imagine this site would look like. And then these kind of, if we think about this project, SANE project, then this kind of potential, if the decision is about heat-only production, then the possible or potential heat-only production technology providers are Calogen and Steady Energy. And this is then sort of how it looks, how their journey looks like. So they are at the moment in the program preparation phase, and what they are doing at the moment, they are assessing business models, plant vendors, and site alternatives in 3 locations in Helsinki. And one of the locations is very central area in Helsinki, and others are a bit to the east side of Helsinki. At the same time, environmental impact assessment progresses alongside with a continuous dialogue with the city residents, and also a zoning process is initiated. And they consider to have readiness for site selection around turn of this year and the beginning of next year. And here you can see how they have sort of visualized this kind of a journey. And then, okay, so what have we done in this SANE project and what kind of data we have collected? And I have here just have a little sort of a timeline what we have been doing. So we have this kind of collaborative approach. We are not conducting surveys, but we are having more qualitative stakeholder discussions, meetings, interviews, and co-designing workshop to explore these perception information needs, and also grasp also these effective engagement methods. And we started with this kind of mapping with them, and this content description means more about what our case study consists of. And now what I will now soon present some draft finding is about this kind of perception of these key authorities. So Radiation and Nuclear Safety Authority, Helsinki City Zoning, and emergency departments in that area. And we will further go on with this project to reach non-Finnish speaking residents in Helsinki and organize a workshop co-designed with these other stakeholders. And what comes out of this is then part of this, our report related to socio-technical boundary conditions and lessons learned from this study. And okay, here the next one is still about sort of describing, if anybody is interested, what this data is about. So these are about the interviews and the companies and the themes. And then we organized, that was fast. We organized also a workshop and facilitated the workshop for the authorities. So, and then if we go to the draft findings. So first we start with the risks. What were sort of the perception of these SMRs and nuclear safety risks in this urban environment? Specifically, now we talk about this Helsinki case. So what came up here was these kind of issues like these urban settings reduce margin of errors. And the population proximity, dense infrastructure, and limited space increase sensitivity to modeling assumptions. And these risk assessments rely on these assumptions, like dispersion and dose calculation, and representations of the built environment remain core in current models. And what was sort of the issue was sort of small uncertainties matter in this kind of context in urban environment. So minor modeling or input data uncertainties can significantly affect conclusions in this context. And these safety zones have planning consequences. So definition of safety and emergency planning zones directly affect land use, zoning, and rescue service operations. And this was sort of the topics that were discussed in the interviews and on this workshop as well. So if I sort of clarify here these kind of key issues, so decisions are sort of made in a way under uncertainty. So land use and zoning decisions are made before full safety analysis are available. And what happens then, how does this affect here is sort of you have to communicate still. You have to communicate these uncertainties between the key actors. So in this case, the licensee applicants and also these different authorities, municipalities and regulators. And also you have to communicate these uncertainties towards the public. And then other topic that comes out of this, that now you have flexible emergency planning zones, and these site-specific zones definitions increase this coordination need between regulator, plannings, and rescue services. And this was one issue. So how can we sort of make this happen, that we are not making decisions sort of that are affecting, because the land use decisions have a long-term perspective as well. So. And then, of course, when you start collaborating with the regulators and license applicants, so how do you balance here with the coordination versus independence, and how you enable this early coordination while maintaining this regulatory independence? Because as we talked, we are still high trust society, but this is also that these kind of issues can sort of start hindering the trust if this is sort of mixed or there is no independence for regulatory bodies. And then here some sort of insights about this coordination and collaboration issues. So this early collaboration topic, which is sort of this planning, siting, preparedness, require early interaction between city license applicant, regulator, and rescue services. But there is this kind of a dynamic. So city at the moment, they don't have nuclear expertise. So they rely heavily on license applicants, regulators, and research organizations like VTT for nuclear specific safety information. And then on the other hand, regulatory authorities depend on the information provided by the license applicant as a basis for their assessment and their oversight. But as we know, these technologies are not ready to be bought yet, so this is perhaps the key issue here. So basically the roles between these actors are sort of formally clear, and they have continuous interaction. But in practice, this work requires more ongoing coordination across these organizational boundaries to sort of make sense and create some sort of the shared understanding of the conditions, for example. And then this independence, it should, and it should also be a constraint, but it also sort of this regulatory independence shapes how and when this collaboration can take place, and especially now when we are in an early phase of this project. And this visibility of the role separation matters. And now we have a case in Helsinki that the sort of Helsinki resident-owned company is sort of pursuing this kind of a deployment. So how does it look for the residents? So is those roles mixed? And sort of these issues were raised from the data. This has to be not just in paper to be clear, this separation, but also in practice to maintain the trust. And then something about communicating these risks and making this uncertainty visible. So this was sort of highlight that explaining these uncertainties, these assumption, boundaries, sensitivities, not just risk magnitudes. And this is, of course, I guess, refers, like Tanya said, it's not absolute, so these risks. And then there are different information needs. So authorities and municipalities need these assumptions, scenarios, and implications for land use, decision, and preparedness activities. And then for the residents, it's sort of important to have clear and impartial information on what is known, what is uncertain and prepared for, and how participation is possible. And then this was emphasized as well, that this transparency supports credibility even when all answers are not yet available. And this also sort of was highlighted that you have to make this process, how these answers, the knowledge will be created, and when will it be available also, that it will not be, this uncertainty will not last forever. So when this sort of, in this process, when and how this sort of information is sort of building up. And of course, Finland is a sort of a nuclear state in that sense, so we have well-established actors and roles and procedures here for the purposes, for example, these kind of emergency drills, etc. But the challenge here is what we sort of discovered about this communication, which is sort of a bit contradicting, is sort of that the license applicant is expected to communicate risks and uncertainties, while the regulators cannot take an early front-facing role. But then when you come to the license applicant, how they can sort of balance between promoting the project and sort of highlighting all the benefits and so forth, and then still sort of communicating about the risks reliably. So I guess all in all, what I want to here sort of emphasize is, as a conclusion, is so urban SMR deployment, it's not a technical safety challenge, but also a challenge of this kind of interagency coordination, timing, and governance. And here, of course, I wanted to mention that this technical safety is, of course, just one part of the safety. So we have sort of other operational safety, safeguards, security issues, and also this kind of a safety culture. So the safety is not something stable, it's sort of a emerging phenomenon. And then these early decisions are made under uncertainty, and it requires strong inter-authority cooperation, clear role separation, and risk communication that builds trust by making these uncertainties explicit rather than obscure. But hey, this is what I wanted to share with you today, and I hope to hear any comments or answers related to the topic.
Thanks a lot, Maria. Questions or comments to the presentation? Please, Katrina.
Sorry, it was a wrong hand. But thanks for the presentation, very informative, Maria.
Thanks.
Well, so maybe if I had the floor, I noticed in your one before the last slide, you were talking about these challenges of communicating, because the licensees are expected to communicate, but however, they also sometimes get entangled into project promotion, while the authorities cannot take the forefront. So who do you think, or who do they think that could take this role as sort of independent kind of communicator?
I think that's a crucial question. I think we're gonna sort of address this topic, but I guess we have we have sort of these kind of more independent communities. Is the science community, for example? We in VTT we just published for example, over this topic, we published this short guidance about SMR for district heating to support decision making and ensuring nuclear safety. So it's also, I guess, role for everybody working in the industry, but making their roles visible. So for example, as a science community that we are highly applied science community, we can also provide information and put it in a form that it's understandable for different stakeholders. And we are now translating this also to English in a way to have simple understanding what it requires for these new nuclear communities if they want to pursue with deployment of SMRs. That's one interesting. So I mean, that's a crucial thing. But of course, all of the actors have a role in this sense. And I guess this TUC is very important. People are asking from them because they are trusted, but they are a bit sort of trying also to sort of that, okay, it's a license applicant who has to sort of have the answers about the technology, but they are there to provide information. How do they oversight this and sort of keep up this kind of belief that if it's not safe, it will not go past these kind of critical sort of milestones in this kind of process. So I guess it's a collaborative effort for everybody, but noting that everybody has to position themselves. So what stand you talk about this?
I have one question, if I may, about the communication among the different groups. Do you see, which of course is affected by large uncertainties on both sides? Do you think that one should, or we should, as a community, move forward in this direction? So facilitating the exchange of information which are understandable on both sides?
I think it's good that the science community, if you think that sort of is a meditator, but of course I always also think that if my salary comes from nuclear, I'm not impartial in that sense, so I have to also be vigilant about that, sort of about my position in VTT at the same time. So I think it's sort of I think it's needed, and I guess this webinar was one way also to try to talk about the topics in a language that is understandable. Like I really also appreciated the presentation from our colleague from Energy Ballast, that they were understandable. So we are on the same ground of understanding and going then deeper to the questions about, for example, technical safety of these plants.
Thanks. Other questions or comments? Last chance. Okay, I wish to thank you again, Maria, for your very nice presentation.
Thank you.
We move on to the last presentation of the webinar. So from Mrs. Tanya Pevko from SEK, and the title of the presentation is Evidence-Based Communication of SMR. What can we learn from social studies? So Tanya, the floor is yours.
Yes. Thank you so much. I would like to thank also to Maria and to Robe and to Katrinel, because my presentation builds on this evidences, this research that has been done previously. I will talk about the communication, steps in communication. And we know that in communication, we always need to define objectives really well. So what is our objective? Clarify what do we want to achieve? Are these attitudes? Are these actions-oriented behavior? For instance, is this I don't know, that people would come to the meeting and that they would contribute to the meeting, or is this, I don't know, the positive attitudes about the politicians or the public resources and so on. So the objective, how do you define the objective of the communication, is the most important step in the communication, because if objective is not well defined, then communication is lost. So when you have the objective, then you identify facilitators, barriers, and drivers of these attitudes or this behavior that you want to achieve. And in the presentation of Maria and in the presentation of the Robe and Katrinel, we could see what are the facilitators, what are the barriers, and what are the drivers of the people's attitudes and behavior from the empirical evidence. And then when you have this, when you do the research on this and you know what are the drivers and barriers, only then you can start developing communication. And communication means that you plan the dialogue, not only top-down information. And for this, you choose appropriate tools and the methods. And then you test it with some groups, you improve it, and then you apply it in the field. And when you apply it in the field, then you also evaluate. You need to evaluate effectiveness, where you assess whether the results are against the objective, where you really achieved what you defined in the beginning. For instance, if you wanted that, I don't know, that 50% of the local communities attends the meeting, then you can measure whether they really attend, the 50% of community was really there on the meeting. This is a simple stuff. And then you improve it and you continuously go into this circle. But what is also important in nowadays society, in democratic society in Europe, that you bring also legitimacy in communication and into stakeholder engagement. So we can split 3 different legitimacies according to Webler and Rehn. And the first legitimacy, which is important, is input legitimacy. And this is what Maria was talking about, you know, how participation is organized, where the rules, roles, and responsibilities are predefined. Do we know who is responsible for what and how the relations they go? Who is involved? We also need to clarify the purpose and so on. And we really need to focus on conditions before at the beginning of the participation and communication. So, and then the next is process legitimacy, and this is how the process is conducted, you know, whether it's really fair process, whether do we have are we able to put respectful dialogue, do we provide clear information, and do we also enable participants or community or public that they learn about the things, that they learn what the SMRs are, that they learned about the different attitudes, the different constraints, the different problems from each other, and that they benefit from this process. And then output legitimacy is the one that we often forget, at least nuclear sector often forgets. And this is how the input is reflected in the outcome. So we often engage and we communicate and we ask people participate, but actually we don't take into account what people are saying or stakeholders are saying. We just say we engaged, checkbox, you know. But here output legitimacy is really results and how they are used in the decisions. So it really matters that we ensure participation, that it's meaningful participation, that it's credible, that we avoid participation being just symbolic or instrumental because we said, okay, we will engage and we engage in checkbox and so on, and that we also support with communication and participation, informed decisions, and also better outcomes. Because only strong legitimacy requires the right conditions, fair process, and outcomes that reflect what has been heard. So what I will do from now on is completely non-scientific, because I will do the next steps. I will draw my suggestions, my recommendations on the multiple EU and national research projects, analysis on different sources, studies, reports, meetings, white papers, and so on. And it's not systematic. And I would also like to stress that these recommendations are expert informed. Let's say that I'm expert because I have competencies for this, but they are not validated, neither empirical tested. So this is the warning. So my best judgment, how do we need to communicate about SMRs, is so first, I would like to again simplify everything what has been heard from Robe, Katrinel, and Maria. So what it influences level of public support or low support or high support for SMRs. We see many different drivers, from general drivers to structural factors such as the energy security, electricity prices, population density, seismic risk, local jobs, and so on, do psychological factors, perceived, how the benefits are perceived, how the risks are perceived, trust in institutions, and so on. Also, what it's in the literature known that socio-demographic contexts have limited predicted power. So it's not we cannot really say that we can that one specific group consistently oppose or support SMRs and so on. So the age, education, income, gender, residential context, and so on. Where do you live doesn't has a limited predictive power, but then also awareness and knowledge. We cannot ask people to make an informed decisions if they don't know about the SMRs. If they don't have some precondition, which is being aware and have some particular knowledge, but of the next predictor, driver of the public attitude, which has been stressed by Maria and by Robe and Katrinel, is the governance. And this is institutional credibility, quality, for instance, in environmental impact assessment process, meaningful participation, and so on. So these are all drivers. Okay, so now the first step, we identify the drivers for the public level of public support or this not support for the SMRs, and now we need to go to the communication. So what does this imply for communication? I would like to stress that communicating about SMRs depends a lot of the framing, understanding, but also on opportunity. So we need to focus on SMRs. We need to know that how they are framed and how they are understood. Communications should go much beyond the yes or no debate. Yes, SMRs or no SMRs. They should explain what SMRs are, why they imply, and how they are assessed. For instance, what is small? We need to define what is small. For instance, we could hear from the first presentation, you defined the small based on the electrical output. But I guess that people for instance, when we conducted focus groups that Robe presented, they imagined small also in the size, how big they are. Is this like house? Is this like factory and so on, you know? So we need to explain what small means in practice. And it would really be helpful if the project defines what is small for you, but also if there would be, how to say, consistent definitions also in the numbers, because numbers, they give us credibility. And then also to explain multiple modules. What does it mean, module? How does it look like? People cannot imagine this. Clarify why design may use more than one module, and to be also open about economics, you know. But we also need to recognize opportunities, but also risks. You know, we need to always acknowledge both the potential benefits and the concerns, including safety, waste, cost, how much it will take, that it will be built, and so on. And we really need to avoid portraying SMRs as purely technical, because these are socio-technical decisions. So how should communication respond to different drivers on public attitudes? Because the drivers, they were explained also in the previous presentation, but also in the studies. For instance, the evidence shows that electricity price and affordability strongly shapes support for SMRs. So what this means is that economic context matter more than ideology, and what it could be recommended for communication action: acknowledge cost concerns explicitly, explain how SMRs relate to affordability and price stability without promising low prices. Then, for instance, energy security and domestic or EU fuel sourcing increase support, we know this from the evidences. So we know that SMRs are evaluated into huge geopolitical context. So when you communicate, link SMRs to energy security, autonomy, reliability, and avoid purely technical framing. So, but be truthful, you know, so don't say, for instance, I mean, related to the fuel, be truthful, whether fuel is in Europe or is not. Don't exclude it because the public is not naive. Then, for instance, we know that site characteristics, they also affect acceptance or support for the SMRs, distance, population density, seismic risk, for instance. We really identify in the evidences that local context is really decisive. So tailor communication to local conditions, address site-specific risks and benefits transparently. Then, like I said, no socio-demographic groups consistently support or opposes nuclear. So targeting by age, gender, education is not so effective as we would wish to be. So let's avoid demographic targeting, do more segment audiences by concerns or by engagement level instead. Then perceived benefits, risk, trust, fairness, in the process dominate also the attitudes, how people will feel about it, you know. So in this case, we can focus on risk-benefit balance, fairness of the process, and transparency rather than persuasion, rather than promoting the things. So transparent presenting. And then also what is known, what has been known in the literature is that political cues have limited impact and can also paralyze. So partisan framing backfires. So if you only present positive things and only propagating, this really backfires. So use non-partisan language and messengers. Avoid for and against narratives, but be more broader. Messengers, for instance, these are the politicians. For instance, they are not good communicators, not recognized as trustworthy communicators about this. Then baseline knowledge of SMRs is low everywhere, but we know that many public views are first impressions. They don't make their decisions about the SMRs on the awareness, on the deep knowledge and so on, but it's just an impression. So then it's what is important in communication, that we start from basics, that we explain what SMRs are, how they differ from large reactor, and also what is uncertain. Then, for instance, knowledge of nuclear as a low carbon correlates with the support for nuclear. So the climate framing really matters. Explain nuclear role in CO2 reduction while acknowledging also trade-offs, risks about this. Then knowledge gaps about the SMRs and also environmental impact processes are really widespread. There are a lot of misunderstandings that they can fuel uncertainties. So explain the process, for instance, also environmental impact assessment, scope, how public input is used in this process, really important. And then, for instance, that public attitudes are pragmatic and mixed, which means that if they support, it still doesn't mean that you are enthusiastic about it, you know. So that's why in our communication, everybody needs to avoid advocacy tone. Recognize cautious acceptance and also skepticism as legitimate. You know, don't ignore those things. And then stakeholders also question costs, how much it will cost, when it will be done, what is the scale, and whether it's feasible, you know. And this, if you want to be credible information source communicator, it really requires realism, you know. So we need to address economic and deployment challenges openly, especially with expert audiences, you know. Don't pretend that it is not. We need to take a realistic approach in communication. And then, for instance, SMRs are perceived as smaller, safer, but economically uncertain. And this small is ambiguous, you know. We really need to clarify what small means, explain design and evolution and multiple module logic. what is small for you, it's not necessary that it's small for me. And this is really tricky word that will backfire us if we are not going to start communicating it clearer. And then concerns about waste, safety, long-term stewardship are really persistent, and this also ethical dimensions, they matter. So address these waste things in your communication, address accident scenarios when you will communicate, and also long-term responsibility explicitly in your communication. And then also that perception differs across countries by proximity. For instance, the context really shape interpretations. So adapt messages to national and local context and avoid one-size-fits-all messaging. And then the last evidences relate, for instance, to strong demand for clear, independent, factual information. This is what Maria was saying, independent. Who can give it? Who is the communicator? It really, trust depends on clarity, So use structured and accessible formats, distinguish facts from assumptions, opinions, and also uncertainties in your communication. So every communicator has also probably opinion, because like Maria, she said, I always acknowledge that I'm in the employed, that my payment depends on the nuclear, so this is really clear and transparent. So, but if she's going to present facts and split it away from her opinion and her assumptions, this will be completely accepted, and it will give a trust that she will be recognized as trustworthy. Then scientists and research institutes are most trusted. So who is the messenger? It really matters. So prioritize scientific voices, limit reliance on politicians, because all studies, they show when politicians start to discuss, public gets polarized. And this we don't want to. It's not only black and white, it's only yes or no, but there are all rainbow in between. Then some public wants involvement, not just information. One-way communication is definitely insufficient. So create dialogue formats, especially early, and use different participation tools for public deliberation. Then related to poor environmental impact assessment participation, which also reduces support. So integrate communication with participation, show how input influences decisions, and this will help a lot. And then what is never, what we always need to stress to our colleagues, that is the overly optimistic or deterministic rhetoric undermines the trust. Credibility is really fragile. So avoid claims or solutions, or cautious, be really cautious and precise in language. In the documents, for instance, of the Nuclear Energy Agency, when they speak about the SMRs, they still are saying that they are safe, not safer. They say safe. They say that they are cheap, not cheaper. And so we need to be really cautious when we are speaking about them. Oops, why it doesn't want to go down? So how to make all this in practice? What I said. For instance, here I drafted some key messages that we can use, how you can say the things. For instance, the first one relates to the risks and uncertainties. For instance, you can say, like any energy technology, any SMRs involve risks that must be carefully assessed and managed. Safety, waste management, and protection against accidents or external events are central issue in ongoing research and evaluation. These questions are not assumed to be solved in advance and are examined through regulatory review and environmental impact assessment. So in this case, for instance, we expressed really the uncertainty, we express the risk and so on. Or for instance, here related to the costs, we can say costs are one of the main questions surrounding SMRs, At this stage, there is uncertainty about the construction costs, electricity prices, the competitiveness compared to other energy technologies. So these economic aspects are therefore a key focus on ongoing assessment and socio-economic research. So it's really recognizing all this what I said before, and for instance, the middle here, about the advocating, also respond on the previous discussion. For instance, you can say this information is provided by researchers and technical experts working on nuclear safety and energy systems. Our role is to explain what is known, what is uncertain, and what is being studied, rather than advocate to specific energy choices. So definitely the purpose of communication and when we discuss with the people, when we have the different opinions, I said that we have to cherish also the opponents and address them and so on. For instance, we can respond like here in green below. We can say the purpose of communication and dialogue on SMRs is not convince everybody to agree, but to ensure that decisions are informed, transparent, and considerate of social concerns. Constructive disagreement is part of this process. And here you will see also, when you will read this later, you can also see that how to respond, that some decisions are not taken into account and so on. So it's possible to address this, all this what we discussed before in the normal language, and to admit uncertainties, admit risks, and so on. So what leads to long-term impact? Dialogue and engagement, or top-down communication. I would like to stress here something about what shapes risks acceptability, which was somehow this discussion was opened with our first presentation. It's not about so much about the risks and the consequences, probability and the consequences, but it's more psychological factors, which we call psychometric paradigm. And we know, for instance, the feelings like dread, familiarity, controllability, volunteerness, and so on. These are one of the most important things when people think about whether we want to live next to the SMRs, for instance, And if we are going to address these risks, for instance, the dread, to reduce the dread, we need to promote emergency preparedness to build confidence and reduce fear. So the emergency preparedness is part of the things that we openly need to discuss, to enhance familiarity. For instance, we can make an open house events, participatory forums, and so on, where we will not only explain, but we will also listen and together work on the things, So all this, how do we reduce how do we respond to these psychometric risk characteristics is action. And if we think about the action, it means that we let people to work with us, to be engaged with us and actively participate. It's not one way, expert-driven communication. It's not that we would say, don't be afraid of this, but we ask them to come, to see, to touch, to design with us, to be engaged, because if we go only one way and we go top-down, expert-driven communication, we will stimulate heuristic information processing, which relies on simple cues and will, for instance, on trust, on one source, on one fast decision, because we like the person that is telling us something. But if we do our decisions based on this leads to really to fragile acceptance. When somebody else will come, we will change our opinion and our position, And if we will work only, on this, trust me, I'm telling you, or we are a credible source of information. If we are telling you that it's safer and so on, you need to believe us and so on. This will also limit understanding and also perceived control. But if we are going to ask people to work together on an emergency plan with us together, for instance, then they will understand what emergency plan is. They will understand what the risks are, and they will understand all processes behind that it will not come to this risk. So the dialogical and participatory communication, where we put people in action together with us and so on, this leads to the long-term the decisions that they are supported with the long term, and people are not changing anymore so much their decisions, you know. So one way, expert-driven communication doesn't have a long-term effect, while the dialogue and participatory communication, this links to the long-term effect. So embedded stakeholder engagement in decision-making really supports more robust, more informed, and also ethically grounded support for nuclear technologies and installations. So what is important for stakeholders and public engagement? What make engagement legitimate? Here again, I would like to go back to these three legitimacies. When we engage with people, we need to look legitimate participation is really achieved when the right people are involved, when the process is really fair and learning orientated, you know, not that this doesn't mean only that the expert in SMRs are teaching people and stakeholders, but also stakeholders are teaching technological experts on the things where the exchange happens. And also legitimate is when the results are meaningfully shape decisions and actions about the SMRs. So here you can see under each pillar how do you what kind of attention points do you have to have when you are thinking about this, you know. For instance, for input legitimacy, how participation is designed, you look into the scope and objectives. How did you recruit people? To whom did you communicate? Institutional commitment as well, you know, while procedural legitimacy is strongly connected to the social learning where people are, where we enable stakeholders and public to work together and to learn together. And then this magic happens when they, through the constructive disagreement, come to some constructive agreement. And we need to enable this in the society. And then the outcome legitimacy, really important, is that how participation informs decisions related to this. So to conclude, I would like to stress that we really need to link communication to participation, and that we need to engage in early and meaningful collaboration at the early stage. But what I would really like that you take away is that as SMR's technology evolves, you know, we are every day we are evolving this. Communication must evolve with it as well, you know, but through dialogue, participation, and collaboration among developers, decision makers, authorities, stakeholders, and the public. And I would like also to stress, when we communicate about the new things, we also do sometimes mistakes, and we try something which doesn't work. Then you go back, you improve it, you evaluate it, improve it, and you try something else. But our objective really needs to be that we together co-develop the decisions related to the SMRs, whatever type it is. Thank you. This would be what I wanted to share with you.
Thanks a lot, Tanya, for your very nice presentation. So the floor is open for questions or comments. Please. Comments, questions? No, maybe I may start. So, Tanya, I have one question. At a certain point, you mentioned that providing more information about the emergency and preparedness is one of the many key points. But you mean in the framework of by including also the stakeholders in the process, or simply providing as many as possible clear information on the emergency preparedness, because this I can really people is not aware of looking at so how to say scenarios which are typical of the emergency preparedness, saying, I don't know, you have to take iodine pits, you have to move here, you have to follow these directions, because so it's
yes, it's a we conducted a lot of research in the NERIS platform about how to improve the preparedness for the emergencies, and the common conclusion is that the stakeholders and public, they need to collaborate. During the emergency itself, of course, you don't involve people. You tell them now to take the iodine tablets, but in the preparedness phase, you know, they need to be part of the preparedness planning. For instance, the iodine pills, you know, how do you distribute them? How do the people understand them? Would they give them to the kids? Would they where they would store them? Do they all these things, for instance, or the farmers? I mean, it's nowadays none of the emergency preparedness plans are not done without the stakeholders and public, because they just don't work. It's
okay.
So it's really and on the other hand also, when we discuss the SMR, something that it will come, I don't know, from in 10 years or so on, and at this moment we still don't know the sources and what are the real risks and so on. It's already time to discuss about this, because people are, when we say the word nuclear, people, they feel that they cannot control, that they are afraid of this, they have catastrophic potential and all these things. But if you already include them and you inform them that emergency preparedness plans are, that you are working on this, and you already include them into this, they will get a feeling of controllability. They will have a feeling of that it's not, they will not be so afraid anymore, you know. For instance, I don't know, if you're afraid of dog, you know, but then you play with one nice dog and so on, then suddenly you're not afraid anymore of the dogs, because you know how to handle the dogs, for instance. This is exactly the same. And also the effect on children and all these things, they highly influence people's perception of the new nuclear technology and SMRs. And if you start discussing this and you involve them in the emergency preparedness, it will address a lot of these social psychological factors that are barriers of the, how to say, the support for the new nuclear technologies.
Thanks. Other comments or questions? Otherwise, I have a second one.
We are a bit over the time already, but okay.
Yeah. So, yeah, we have 7 minutes. No, 17 minutes over the time. This is just a general question to on my side, not only to you, but to almost all the speakers. Maybe not to Paul or Gilliam, but because we are more close to my background of daily work. So, how do you envisage, or it is already reality, the employment of AI in your studies, in your science? And if yes, it is useful, it has some advantages, which disadvantages, ethical issues, and so on and so on. Oh, sorry, Mary has a comment.
Yes, so we have now a research experiment going on that topic. So use AI for risk communication, and it's funded by our nuclear safety program. So we have an experiment with the professors from University of Oulu, and we are testing it in Kuopio, which is the other city that is planning for using SMRs for district heating. So we are sort of having now setting this experimental setting and having trained this lovable AI and train it in a way. And after end of this year, we have sort of solid also research findings about that topic. So this is something we've been sort of because we have this case in Finland, things are actually proceeding fast. So in this sense, we are sort of luckily also got this research funding for this kind of a real life experience with a real new nuclear community and how this tool can be used as a part, not as replacing expertise, but facilitating, co-facilitating the discussion, and also the experts and regulator and energy company and the city are involved as an experts in this experiment. So looking forward to sharing these insights from that research then later this year.
Okay.
Yep. Maybe I can very shortly add. So, well, of course, it's a very broad question how AI could or should play or would play a role in, well, a lot of different social scientific disciplines. Speaking maybe more for myself as a qualitative research sociologist, I think, well, the role of AI is not yet entirely clear. I think currently it is maybe helping us to go through large data sets, like large, I don't know, newspaper article data sets, and kind of helping us to do some kind of sensitivity analysis, for example. In general, however, of course, yeah, the problem, especially with these kind of large language models, is that it's hard to sometimes understand how they have been trained, what kind of biases are also integrated in its training, which makes it very unreliable, I would say, to play a large role in analysis without any kind of human interference. So it's a bit, as Maria points out, like, okay, well, we could maybe look into some of the aspects in which it could help us, but it will, at the moment at least, not replace any of the human expertise that is needed to, in our case, then more, let's say, work towards data interpretation. Yeah.
Thanks. Thanks a lot. So I don't see any other comments or questions. So I think that we may come to the closing. And I wish to thank again Thomas Lobatka and Maria for having organized all of the webinar, and of course Art as a coordinator to have also followed this activity. And I wish to thank really a lot you all the speakers, because it was, in my view, a really interesting half a day. And I hope that we really make this kind of appointment more and more usual, at least in the framework of SANE, but maybe also in the framework of other projects. So I wish you a great day, a great evening, and see you soon. And last words for all. Again, just to remind you that all the presentations will be shortly available on the SANE webpage, and that you can download.
Yes.
Or
just if
correct?
I may quickly, sorry Fabrizio.
Of course.
Yes, all the presentations along with the recording of this webinar, since it's public, will be uploaded to the same website and they will be readily accessible. I will also be sending an email where you'll find a link directly to the presentations sometime next week, hopefully. So everything that's been said here, everything that's been shared will be readily accessible for all your needs. So do not worry about that. And also I'd like to thank everyone who took part. It was great time, even for me. So thank you very much.
Again, thanks a lot on my side. Bye.
Thank you.
Thank you very
Bye
much.
bye.
Thanks a
Thank
lot.
you, everyone. Bye.
Bye.
Have a great day.
Bye.
Thank you. Goodbye.
Bye.